All right, hello guys. We're going to continue with the solving systems of linear equations. We saw in the previous section how to use graphing to do that, where we would graph the two lines, starting with the y-intercept and then using the slope and looking to see where they intersect. And graphing is a good method. It works sometimes nicely, and sometimes there's problems when you don't want to have to use a graphing method. Maybe just the way the problem's set up. Maybe you don't have graph paper, you don't, kind of doing it by hand sometimes is difficult. So there's ways to do it algebraically, kind of more like you feel like you're actually solving equations. And I want to go through a couple methods on how to do that here. Okay, so again, if you remember, the solution to a system is the point where the two lines intersect, right? So algebraically, this point can be determined by calculating when the two expressions for y will equal each other. So for example, there's a worked out example here. You see the system given to us right here. There's two equations there. And the idea is, since they are both equal to y, right, we're saying y equals this, and then also we have y equals negative x plus 4. Okay, so if the idea is if both of those things equal y, right, then we know this equals y and this equals y. So the idea is they must both equal each other, right? If they both equal y, then they equal each other. So you can set them equal to each other and then kind of just go through the normal steps to solving an equation. As you can see, where they go ahead and first off, they add x to both sides. To get rid of having variables on both sides, and then they just go through and solve first for x. Okay, so that's the way it works. You'll solve for one variable first, and then once you get one variable, remember the first equation said y equals 0.25x plus 1. I'm sorry, minus 1, isn't it? Yep, minus 1. That was the original first equation right here. And the idea is, once you figured out what x was, you substitute it back in. You see they substituted 4 in for x right there, and they were able to go ahead and figure out what y equaled. Okay, so let's take a look. Let's do a couple examples and see how this works. All right, so here's a few examples for us to try on our own. Let's see if we can get these going. So we want to solve each system algebraically, showing all steps, and we want to write the solution, of course, as an ordered pair, just like we did with the graphs. All right, so on the first one here, they're telling us that y equals 3/2 x plus 1, and then also y equals 2x plus 2. Okay, now, seeing that they both equal y, what I'm going to do is set the 3/2 x plus 1 equal to 2x plus 2. Okay, and make sure you see why we're able to do that. Okay, if they both equal y, that means they must both equal each other. So we're going to go ahead and solve for x, okay? And since there is x's on both sides, we're going to go ahead and subtract. And let's subtract the smaller one so we don't get a negative. So 3/2 is actually smaller than 2, right? 3/2 is like 1.5. So I'm going to subtract 3/2 x from both sides. That'll cancel, and we'll just have 1 over here. 2 minus 3/2, again, 3/2 is 1.5. So 2 minus 1.5 is going to leave us with 1/2 x plus 2. And then we can go ahead and start getting x by itself. We'll subtract 2 from both sides. Okay, so that'll cancel. And then 1 minus 2 is negative 1. Negative 1 equals 1/2 x. Okay, let's see if we can move this up a little bit. There we go. And then to get rid of the 1/2, we have two options. We can either divide both sides by 1/2, okay? But remember, dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to just multiply by 2. And 2 times negative 1 is, of course, negative 2. So we have our x value, negative 2 equals x. Now, we're not quite done yet. We do need to still find y, okay? Now, remember, that's a lot of times people get one variable and then they kind of think they're done, but we are not done yet. We need to now substitute this back into either equation. I'm going to substitute it into the second equation because it didn't have the fraction. It just looks a little bit nicer. So I'm going to sub into the equation that said y equals 2x plus 2. Okay, so since we know what x is, I can plug that value in right there. It's 2 times, we know x, we found x was -2, right? Plus 2. So y is going to equal, we have 2 times -2, so -4 plus 2. And -4 plus 2 is -2. Okay, so we got x equals -2 and y equals -2. So our solution as an ordered pair is -2 for x, -2 for y. Okay, and that is where those lines would intersect if we had used the graphing method. This problem actually would have been a good candidate for graphing. Because of that fractional slope, sometimes you don't want to deal with the fraction in the arithmetic. But graphing a fraction isn't, as a slope is not bad at all, right? It's just a rise over run. So if this problem showed up for me and I had access to graph paper, that might have even been easier. But some will not be easier to graph. So let's take a look. Part B is very similar. Let's look at part C. It just appears to be written a little bit different, but same kind of idea there. With part C, we have y equals 5x plus 1 and y equals -4. Okay, so let's go ahead and set them equal to each other. Okay, so 5x plus 1 must equal -4, right? I'm setting the 5x plus 1 equal to the -4 because they both equaled y, so they're equal to each other. And this one's kind of nice, right? Look at this. We don't even have to worry too much about having variables on both sides or whatever. We can just solve for x right away. So I'll subtract 1 from both sides. 5x ends up equaling -5. And then, of course, we can divide both sides by 5. And x equals -1. Okay, so x is -1. Now, what are we going to do to get y? Okay, we got to plug it into one of the original equations. But take a look. Look at what equation, the second equation, told us that y equaled -4. Okay, so we actually kind of already knew y from the very beginning, didn't we? Hopefully you guys caught that. So y equals -4. So our solution for this one, -1 for x, -4 for y. All right, let's go through one more example using substitution. This one's a little bit different, okay? If you notice, the way they're written, they're not both solved for y, okay? So sometimes with substitution, you need to do a little work. So let's take this, I'm looking at this first equation, okay? And if we want to solve this for either variable, so we can then substitute something in, this one's going to be easiest to solve for x. Okay, so let's actually subtract 2y from both sides. And we're going to get x equals 8 minus 2y. Okay, and what that'll let me do now, that will let me substitute this expression right here, 8 minus 2y, can get substituted in for this x right here. Okay, and let me just write it and then we'll talk about why that helps us. Okay, so let's substitute that in. I'm going to call this equation 1 and this equation 2 just so we have them named, even though this is, again, it's one problem, but there's two equations. So if we substitute that in, equation 2 says 3 times x. I'm going to use 8 minus 2y in place of x. Okay, and just rewrite the rest of the equation. Okay, so notice this x again just became that. Okay, so make sure we're clear on that. I chose to do it this way because it was easiest to solve that first equation for x because it didn't have a coefficient that I would need to divide by. All I had to do was subtract 2y. So that was just kind of the easiest method. And what ended up happening, we get ourselves a new equation, this third equation in red here, where it's only in terms of y. So we're going to be able to solve it for y. So let's do that. Let's take a look. So we have this 3 needs to get distributed. So 3 times 8 is 24. Minus 3 times 2y is 6y. We still have the minus 4y. And then it still equals 4. Okay, and now we can keep going. 24, the minus 6y minus 4 more y is minus 10y equals 4. Okay, and then we could go ahead and keep going by subtracting 24 from both sides. So negative 10y equals negative 20. Okay, divide by negative 10, y is going to end up equaling 2. Okay, so we got our value for y. Now, just like before, we still need to go and get x. So in this case, it's probably best to use this equation written that way because that's already solved for x. So I'm going to go ahead and substitute in the y that we just got. X will equal 8 minus 2 times, we know y, we just found equaled 2. So x equals 8 minus 2 times 2 is 4. And then 8 minus 4 is 4. So our solution here, right, our final answer as an ordered pair, x always comes first, then the y. Okay, so sometimes you have to do a little work to get things set up. I want to show you that there's actually another option for this problem in particular, another method as well. Over here, when we did it the other way, okay. Okay, so here's that same problem. I want to give you guys one other alternative method that sometimes work, and I'm going to number these equations again, even though, again, remember, this is one system, right? This is one problem, but it does consist of two equations. So we showed previously how to do this with substitution, and with substitution, what we ended up doing just a minute ago was solving the first equation for x and then kind of doing some substitution. But this one, if you kind of notice how things are lined up, meaning like that, the way the equations are written, you have the x's here, then you have the y's, and then you have the constant terms here. When things are lined up like this is actually called standard form. A different method might be a little quicker, okay? And that method is known as elimination or sometimes linear combinations. And basically the idea is we can add the two equations straight down in an attempt to eliminate a variable. Okay, this one we can't do, if we did, just think about it, if we added right now, it'd be 3x, x plus 3x would be 4x, the positive 2y minus 4y would be minus 2y, and the 8 and 4 would be 12, and what we're looking for here is we wanted to eliminate either the x or the y, so we would be able to solve for the one variable that's still there. Okay, so as written, as we did this, it didn't work, right? We still have x's and y's in here, so what we need to do sometimes is multiply one of the equations by something, and in some cases you have to multiply both equations, but in this case there's two options. I'm looking at either eliminating the x or the y, it doesn't matter, but to make that happen we would need to have like a plus 2y in one equation and then a minus 2y in the other. We would need them to be opposites. So what I'm looking at is with these y values right here, okay, one of them is positive and one's already negative, and one's a plus 2, one's a minus 4. So here's what I'm thinking. If we were to multiply this top equation, let's write that with a pen. If we were to multiply it by 2, just notice what happens, and then I'll kind of talk about what I was looking for. Okay, so we're just distributing a 2 to this entire top equation, and since we're doing it to both sides of the equation, we are allowed to do that. Okay, so it would become 2x plus 4y. Don't forget to multiply that 8 by 2 as well. Okay, the second equation I'm not touching at all. It was 3x minus 4y equals 4. Okay, here's why that helps us. Okay, when I now go to add these equations straight down, okay, this method is also known as the addition method, along with elimination, has a few names. Notice what happens. The 2x plus the 3x becomes 5x. Okay, the y's now do eliminate. That's what we wanted to happen. That's why I multiplied by 2 here to make that happen. Okay, the 16 plus 4 is 20. Dividing both sides by 5 will get me x equals 4. Okay, and we got one of the variables really quick. Okay, now we do need to go back still and substitute to find y, so we can plug it into either equation. I'm going to plug this into, or substitute into, the original first equation, just because the numbers were a little smaller. The first equation said x plus 2y equaled 8, but now we know what x is, so I'm going to plug in 4 for it. So 4 plus 2y must equal 8. Let's solve that for y, subtract 4 from both sides. Okay, bring down the 2y equals 4. And when we divide by 2, we get our answer of y equals 2. Okay, so we still got the ordered pair 4, 2. Okay, it just maybe was a little quicker. Okay, and you can decide based on how the problem is set up if you want to do the substitution or the elimination. Okay, so let's do one last elimination method, and then you guys can get some practice on that. Okay, let's look at an example here. Let's look at example A. Okay, so as written, let's do it over here so we have some room. 3x plus 4y equals 17, and 5x minus 4y equals 7. Okay, so this one for sure, this one's jumping out to me as elimination, the new method, automatically, because take a look at what we have given to us right here. Okay, and if you have that case, it could have been the x's or the y's. If they're opposites like that, elimination is going to be really quick, because when we add these equations together, 3x plus 5x is 8x, 17 plus 7 is 24, and of course these y's eliminated. Okay, we got ourselves a brand new equation that's really going to be quick, okay, to solve. We'll just divide both sides by 8. X is going to equal 3. Okay, we got x right away. Now we do need to go back though and find y, so we can substitute it back into either of the original equations. So it doesn't really matter. I'll just substitute it into the first one. The first equation right here said 3x. So 3, we know x is 3. 3 times 3 plus 4y equals 17. Okay, so I'm just back substituting the answer that we got right in for that x. 3 times 3 is 9, plus 4y equals 17. Okay, we can then subtract 9 on both sides of the equation. 4y will equal then 12. And when we divide both sides by 4, 12 divided by 4 gets me y equals 3. Okay, so our solution was the point 3, 3. Okay, and that's elimination or linear combination or addition. You know, they have a bunch of different names for that method. That would have been easier in this case than doing substitution, because substitution, we would have needed to solve one of the equations for x or y and then kind of substitute into the other one. And it would have got messy because each of the terms had a coefficient here that we would have had to eventually divide by. So I would highly recommend when you're doing these, look at the problem, kind of come up with a plan, think about which method's going to be easier, and then take it that way. All right.